Welcome, everyone. You're in room 355 ABC. And we have Nandita Viswanath and Sagar Aryal. And they're going to be talking about in-house to open source, stitching the past to the future with Python.
Hi, everyone. I'm Nandita. I'm a software engineer at Bloomberg.
And I'm Sagar. I'm also a software engineer at Bloomberg.
And we're going to be presenting our talk, In-House to Open Source, Stitching the Past to the Future with Python. So today we're going to be discussing how you can leverage open source software when thinking about migrating away from legacy code. Our talk is loosely broken up into 4 sections. We're going to start with an introduction. We'll then move on to identifying our right open source candidate. We'll touch upon how you can integrate your open source candidate into your existing tech stack, and then we'll wrap up with some conclusions. So before we jump into why you should think about open source for migrations from legacy code, let's first understand what legacy code even is. Legacy code is typically code that's no longer engineered, but is just patched for fixes. So it becomes nearly impossible to add new features, which makes them great candidates for migrations. So when you're thinking about migrating software, I think open source should be one of the first things that come to mind. And the first reason why is because you already have access to high quality pre-built software. Chances are there's already software within the open source community that can address your needs, even if not entirely, to an extent large enough that it would take minimal effort for you to go in and tailor it to your specific needs. Which brings me to the second big advantage, customization. Now, since the code is open source, you know what's going on. You can maybe just add a plugin to tailor it to your requirement or go in and modify the code base yourself. Another advantage is that in some way you have access to latest innovation. As more and more people start adopting that open source software, more people become invested in its growth and development. So in a way, you're always on top of the cutting edge technology. And it's not just me saying this, we're all at PyCon. Surveys have also found that IT leaders think the usage of open source is going to boom over the next couple years. But even while open source is great, there are some things to still keep in mind. The first is that support and maintenance may not always be available. But there are some companies and enterprises that offer maintenance at an additional fee, so that's something to keep in mind. The other thing to keep in mind, especially when you're building critical applications, is the maturity and the stability of the software. If there is an issue, you might end up relying on someone to fix it, or you might have to step up and fix it yourself. So that's an added consideration. And the last is that usage of open source does not eliminate hardware costs. You have to budget for hardware if you want to adopt open source at scale. At this point, I want to introduce our case study that we're going to be walking through as the talk progresses. We're going to be trying to migrate an orchestration framework. So let's think of a really complex framework that has to use some metadata to decide to schedule some processes, and then has to account for process dependencies, monitor events, and then finally write some data to a database. Let's build a little more clarity around that. So say we have some metadata, based on which we decide we need to schedule a process. Our process is that little red circle you see there. Triggering that one red circle can actually set off a bunch of other processes, our purple circles, which can in turn set off another set of processes, our orange circles. So our red circle is not really done until all of the purple and the orange processes complete. And like I said earlier, what these processes are doing is just writing data. And we're looking at data in the range of about 50 million data points. But this is when the complexity really kicks in. We don't want to just schedule and orchestrate one of these red circles. We want to do hundreds of such processes and in turn write billions of data points with no room for error.
Now, next I'd like to talk to you about how it is that you can actually go about identifying the software that you want to migrate towards. We're going to go through this in a 3-phase approach. The first being understanding your requirements, identifying what it is that you're actually looking to replace, and then researching for a solution that would address these requirements. And finally, you want to narrow your solution, you want to narrow down the potential solutions that you've come up with to one final system. So in terms of understanding your requirements, in our use case, we had to first get rid of all the business logic as well as the specific intricacies that were unique to our problem and try to boil it down to the highest level. We came up with one sentence that we believe perfectly describes our use case, and that is the automated coordination of events and data streams leveraging domain-specific metadata to intelligently schedule and trigger processes. It's a bit of a mouthful, but from this we can derive these three keywords that describe the system, and that is scheduler, orchestration, and dependencies. Now, we came up with a list of must-haves as well as nice-to-haves. In terms of the must-haves, obviously modeling dependencies, that's the first and primary goal. We want processes to be able to trigger other processes. We also want to be able to do this for historical runs, and obviously we want permissioning. Since this is going into production, we want to make sure there's no vulnerabilities. Performance is also another consideration. Like I mentioned, on a production cluster, we don't want it to take up all the resources. In terms of nice-to-haves, we did say that a user interface as well as the ability to monitor all these processes would be nice to have, not necessary though. And parallelization, these processes are being run on off-peak hours, so it wasn't a necessity. Now, when it came time to research, obviously the first thing everyone does is goes to the internet, right? You take your keywords and you post them into search engines and you try to come up with potential options. Going about this, we eventually landed on Apache's website, where most open source systems are. We found two systems which closely match what we're looking for, namely Apache NiFi as well as Apache Airflow. And another way that we were going about doing research was word of mouth. Obviously, conferences like PyCon can give you potential solutions that might fit your use case, as well as networking, from which internally at Bloomberg we support Argo. That's another solution that we came across. So we have these three potential options. We want to first figure out the evaluation criteria. How can we narrow it down to a specific system? So we broadly categorized it into these four different metrics. First being adoption. So systems that have more GitHub activity are bound to have more support. You know, your questions will be answered quicker. Any bugs that come up will be fixed sooner. So that's a very important one. Then compatibility. Does this system meet your technical requirements? Does it address the problem that you're trying to solve? And then, of course, extendability. Once you do integrate an open source system, it'd be nice for it to eventually evolve into something more. Can it address other problems that you haven't particularly foreseen until you start using it? And then finally, ease of customization. No system is a perfect match, but if something is flexible and is easy to customize for your specific use case, then that's obviously better. Now, this is what we ended up categorizing these three systems into. And Airflow was a very popular Apache project. It's very actively maintained, very extensible, lots of plugins and lots of support for them. It's very flexible with permission control, and it's very easy to adapt. It's actually pure Python. Apache NiFi, also a great solution, but it didn't match our use case specifically because it's very data pipeline focused. Now, we do already have the ETL infrastructure. That's not the part we're trying to replace. So it didn't exactly match what we were looking for. Argo, again, it was supported internally at Bloomberg, so that communication link is even more direct. That's why it had such a high rating on adoption. But it's focused on containerized applications, whereas we're looking for more of a bare metal Linux solution. Again, this is very subjective evaluation criteria for our specific use case, not necessarily going to be true everywhere. Now, Apache Airflow, like I mentioned, it's based around the directed acyclic graph, DAG for short. It's pure Python, like I mentioned. It didn't support every particular use case that we had, but it had a lot of support for plugins, and we did find plugins that were very useful. And of course, a very nice and easy to navigate web UI. Now with that, I'd like to hand it off to my colleague Nandita.
Okay, great. So now Sagar has helped us pick Airflow, and we know Airflow is what we want to migrate to. But where do we even start? We have this huge complex framework that's been working just fine. The only issue is that we're not able to, iterate and add new features to it. And it's doing a lot of things. It's monitoring for dependencies, it's writing billions of data points. There's so much scope for error. So before we even move further, let's break this down into independent but connected components. What are we really dealing with here? We have a scheduler that uses some metadata to decide which process to kick off. We have an orchestration engine, possibly, that kicks off that first process and monitors it for completion. And we have, let's say, a job management system that monitors the dependent processes that were kicked off. These are the three independent chunks of this huge framework that we're trying to migrate from. If we want to move away from all of these three in one big bang, there's just a lot more risk and the scope for failure balloons. Instead, we could just start by replacing the easily replaceable components. To me, that looks like the scheduler and the orchestration engine. So we can just try removing the scheduler and the orchestration engine out of that framework and replacing that with Airflow. But how? The scheduler, orchestration engine, job management system all work perfectly together because they were all natively integrated, and they were probably built around the same time. They were built to be compatible with each other. But then when we integrate with an open source solution like Airflow, it's not been built for our specific use case, but it still works really great. So we need a way to really make Airflow and our job management system kind of speak the same language. And I think we all know where I'm getting at with this. We're at PyCon. So this is where we want to introduce PyHero, our Python component that's going to help stitch together Airflow and our legacy job management system. And we have a lot of superheroes out there, so why should we think of PyHero? There are essentially 3 superpowers that we're really looking for, right? We want to be able to integrate easily with our existing code base. So it should be easy for us to integrate with something that's not necessarily Python based. The second superpower that we want is we need to be able to write this component really quickly. Eventually, in the future, our job management system is going to go away too, and Airflow is going to take over everything. So at that point of time, PyHero will unfortunately have to step down. So we don't want to invest too much time building out PyHero if he's eventually just going to go away. And the third thing that we're looking for is production quality PyHero. Even though PyHero is temporary, it still has to be production quality, because we want it to run in production. We cannot cut corners in terms of its performance. So let's now jump into discussing how Python possesses all of these 3 superpowers, starting with how we can use it to integrate with an existing stack. So let's assume the worst case scenario. Our job management system is not Python at all. It's built in a completely new language. Now we need Python to kind of interface with it. What are the different ways that we can go about this? The first is, like I said, an interfaced approach where we want to directly use our non-Python components within our Python module. In this case, we have honestly multiple options. If you had like a C or C++ library that you wanted to use, you can compile it into a .so or .dll file and then import that within your Python code. An alternative would be to use the Python API to expose our C, C++ libraries via a Python interface. But both of this will require you to kind of go in and modify your libraries themselves. There is another easier non-intrusive approach that you can take, wherein your non-Python components are treated as independent entities in themselves. You modularize them and package them as executables, and you just invoke them as subprocesses from within your Python script. So this is where you really have to kind of balance your requirements, and you have to make a trade-off. If you have things within, let's say, our job management system that we want to reuse even after our migration is complete. So let's say we had a C++ library that was super powerful that we intend on using even after we fully move to Airflow, it might make sense to just go with the first approach, even if it's going to require more development time. But in our case, we were really looking at completely replacing our job management system, in which case it was just easier for us to modularize it and package it as an executable and invoke it as a subprocess. So now that we've discussed how we can integrate Python with an existing stack, let's move on to discussing how Python can help us write production quality code quickly. So we've talked about how we want this PyHero component to be running in production. And one of the most important things that comes with is awareness when something goes wrong. When something goes wrong, you don't want to find out, let's say, hours later or days later. You want to know as soon as PyHero went down in production. And to do this, we actually found ourselves using a feature of Python that most of us are already aware of. I learned about it in theory too, but this is how we could really see it being used while writing production quality code. So we have a decorator that we use within our group that takes in 3 arguments. It takes in a severity, a group, and the name of the component. And based on these 3 arguments, it creates a ticket and with the appropriate severity level and routes it to the correct group. So all it does is really just wrap the function code in a try-catch block and create a ticket based on the input parameters and route it when something goes wrong and execution fails. But this was great when I was trying to come up with this component quickly because I could just focus on writing the core functionality of my module without worrying about the bells and whistles around alarming because it really just came for free. But it's not just sufficient for us to be able to write our code quickly. It's also important that we're able to debug this code quickly, especially when we're interfacing with a legacy component.
With that, I'd like to walk you through an example of a bug that we faced when trying to implement Airflow and how the PDB as a superpower of PyHero really came in to help and save us. So here we have a screen, the login screen for Airflow, and as you can see there's an error message at the top. So the way that we generated this was we tried to sign in using SSO, which redirects us to the SSO page. And we log in and it redirects us back here. Now we knew the credentials were correct, so that wasn't the issue at hand. But we didn't really have much other information on this page about what's causing this. Now, the first place anyone really starts to debug is by checking the logs. And when we did check the logs, this is the only message that really came in with any relevance. It was this error message right here. Now, we see that there's some issue with OAuth. We see something about an invalid audience, but it's still fairly abstract. It doesn't give us much information. However, we do know exactly what line and in what file this error is being raised. So with PDB, let's step into that file and try to figure out what's going on. So we went to that file, and these are the lines that the error was being thrown from. As you can see the log message right there on that fourth line there. And we put a breakpoint. Now, with this breakpoint, we are able to halt execution of the program while trying to log in on the web server itself. And we pause execution, and from there, we're able to observe the variables, including these abstract variables like app builder or .sm. Now, what we realized by observing these variables live is that they were actually instances of classes that we had defined in the web server config.py. So let's dig into this rabbit hole a bit further and see where it leads us. After that, we put another breakpoint in web server config.py, and while the rest of the code isn't too important, we step through line by line to get to this line. This is where the error was really being raised. And so that invalid audience makes a bit more sense. As you can see, the issue is in that key airflow right there. Now, the great thing about PDB is that while the execution has been paused, you can retry lines of code with that environment. And so you could retry other keys until you find the correct one. Needless to say, that is what we did, and it helped us solve this issue. But an issue that was rather abstract to begin with could be solved in a matter of a couple minutes using PDB. So this really goes to highlight some of the advantages of PDB. And first and foremost is that you don't have to rebuild your software every time you put in a new breakpoint. You simply have to restart. And so that's one of the great powers of Python, is that it's much quicker to put in a breakpoint and to then start debugging. There's also a command line interface, which allows for remote debugging. The issue that we showed earlier was debugged on a server. And then it also comes default with the Python language, so you don't have to install it separately or anything like that. There's two ways that you can invoke it. The first one we already showed you in our example is just by adding it into the script directly. And the second one is calling it via the command line, which is very similar to other debuggers you might have encountered in the past. Another aspect of Python that really enables rapid development is how easy it is to customize it. And so I'm going to walk you through one specific use case that we had with Airflow to really highlight this point. And so by default, Airflow uses SMTP for email. And as you can see in the email.py file, it's using some SMTP lib, which under the hood uses SMTP. Now, SMTP wasn't ideal for our use case. It's not important why, but there is an alternative, and that's what we're going to try to implement as a plugin in Airflow. So what we did was we copied this email.py file and we modified it to use the mailx command, which is something we already had code for written somewhere else in our tech stack. And all it required on Airflow side was a simple configuration modification. As you can see here, it's airflow utils.mailx. And this is actually a file path to the actual plugin that we've defined. And with Python, since you can use dynamic importing of libraries, Airflow doesn't need anything else than this configuration change, as well as this file being copied into the correct directory, from which it's able to pick it up and on restart seamlessly integrate and use it for emails going forward. Now that's the function definition that you see there. This was simply copied from the other email.py file, but that was essentially it. And that really goes to highlight how easy it is to integrate your own code into Python code bases. And that's why another major advantage of a pure Python system like Airflow for open source migrations. Great, so now we've spoke to you about some of the things about Python that make it really easy for rapid development. But let's go on to how Python makes it easy to create production quality software. In the case of any open source system, you don't really know the extent to which it's valuable to you until you actually start using it. So the best way to actually learn about an open source system is to use it. And to do that, you have to be able to deploy it into your production system quick. In our case, we were able to deploy Airflow into our production system in an isolated manner using virtual environments. And therefore, we didn't have to modify any configurations or touch any other part of our production cluster. All you really need is one isolated file path where all your dependencies, even the language itself, are going to be stored. And tomorrow, if you don't want to use the system anymore, you simply delete that directory and it's gone without leaving a trace. Now, in the case of Airflow, it's fairly simple since the only overhead was really creating this requirements file, which, as you can see, doesn't have too much extra. After that, you create an isolated build, and it runs on your production cluster, and that's it. Another thing that I'd like to highlight is PyTest is what we use for creating unit tests. And so in production environment, you want to make sure that code changes don't break it. And so before any release, we're able to use PyTest to determine that previously working behavior hasn't been affected. Great, so now we have a half new system and a half old system, and we have Python stitching them together. But we still want to make sure that this half new system hasn't broken anything. So we want to figure out how we can reconcile it. With that, I'd like to hand it back to my colleague.
Okay, great. So now we have, like Sagar said, a half old and half new system up and running. It's churning out some data. But how do we make sure that our old system and our new system are really doing the same thing? One level of a sanity check could be to just check what processes are kicked off by the old system and the new system, and then maybe compare it and see if they tie out. But this does leave room for error, because if we don't capture a failure correctly or a stalled process correctly in the new system, we won't ever catch it. And that's when you really have to ask the question, what is really the output of your system? And like we discussed earlier, the output of our system was data, and it was columnar data to be more specific. So the best way for us to ensure that our migration has gone through correctly and that our old system and new system are doing the same thing is to compare the data that was generated from the old system and the new system and make sure that they tie out. But we're again looking at the scale of millions of data points here, and it can be very intensive to make sure that every one of these million data points tie out correctly. But to help with that, we have a data reconciliation framework that we use within our team, which is built on top of pandas. And if you want to learn more about that, definitely stop by our booth. We'd be happy to chat. So we used that tool to compare the data that was being produced by our old system and our new system to ensure that there were no differences in terms of the output that was being generated. So quickly wrapping up on everything that we discussed so far, let's do a quick recap. So we started with this complex orchestration framework that we wanted to migrate from. We identified keywords and then identified our 3 options that we could potentially integrate with, 3 open source options. We brainstormed, came up with an evaluation criteria based on which Airflow won. And then we broke down our existing architecture into independent but connected components to start integrating with Airflow. And instead of integrating everything big bang, we first replaced the easily replaceable components, which in our case were the scheduler and the orchestration engine. But we still needed a way to connect Airflow to our job management system, and that's where PyHero stepped in. And while integrating with our existing code base, we had 2 options. We could either interface directly with the code components and use them within our Python module, or we could just invoke them as sub-processes. And we went with the second approach, and then added some test cases like Sagar said using PyTest, packaged it with a virtual environment, and then came up with this half-old, half-new system that was churning out some data. But at this point, it was important for us to ensure that the data that we were churning out was in fact correct, and we used a data reconciliation framework built on top of pandas to ensure that correctness.
Okay, so in conclusion, open source is a great option for software migrations. But remember, integration doesn't have to be a big bang. Small steps are usually better. Now, once you have integrated your system, don't forget you want to customize, enhance, and extend it. And once all of that is said and done, don't forget to contribute and give back to the community.
On that note, Bloomberg has recently open sourced, I think as early as 2 days ago, a new memory profiler for Python on Linux. And this can also help you debug the memory usage of your C extensions as well. So if you decide to ever integrate with your code base by exposing your C libraries via Python interfaces, this could even help with that.
We'd like to thank everyone here for helping us with our talk and helping with all the work that went into this presentation. Special shout out to our manager Mahir, who is with us here today. These are our references, and thank you so much for attending our talk. We are hiring, and please do stop by our booth later. Thank you.
Thank you.